We are Team 21035 with the Software-Defined Radio Boards Evaluation Project, and we are sponsored by General Dynamics.
I'm Joseph Emnett, ECE.
I'm Robert Gauthier, ECE and Procurement Lead.
I am Justin Kim, ECE.
I am Franklin Lamb in Systems.
I'm Jennifer Nadolski, ECE.
I am Michael Long, Systems and the Team Lead. For a little background in our project, Software-Defined Radio Board is used for communication between devices through the modulation and demodulation of radio frequencies. General Dynamics has a SDR in their current system that is going end of life in 2025. A new SCR is needed for the system to continue, and we were given specific requirements that needed to be met. A wide selection of commercially available SCRs were to be evaluated. The best fit SCR was selected and tested, and then prototyped to ensure capabilities and quality. Software-defined radios are commonly used in industrial and defense applications. For our project, the end user will be able to use a host device to tune into the SCR and allow them to conduct signal processing and communication throughout the frequency spectrum. Additionally, the maintenance crew/team will be able to service the SCR and adjust the parameters for receiving and transmitting.
GDMS delivered 26 system requirements to be met by the procured SDR. The team then divided these into 4 functional requirements, sectioned by radio frequency, processing, external integration, and interface and power. The team additionally created 2 functional requirements for this project, one for the trade study and another for the prototype. The prototype was further divided into 3 sub-functional requirements, one for receiving FM signals, transmitting signals, and for new radio. Overall, there are 6 functional requirements that cover 35 system requirements. The ConOps of this project include a trade study for quantitatively selecting an SDR that meets General Dynamics requirements, verification and validation tests that justify the selection of the SDR, and a prototype that displays a communication application utilizing the SDR. The following is a system block diagram for the SDR. GDMS requirements were used to design this diagram such that each component is a requirement that the SDR must meet. This is a system block diagram for the prototype. It demonstrates the use of the SDR for transmitting and receiving FM signals.
This project uses the Agile methodology, which breaks down the project into multiple epics, which have sprints that each contain a set of tasks. Our project was a lot different than the other projects, as this was not a traditional design project. We did not have the normal overall design process other than our prototype that was used for testing the SDR we selected from our trade study. Our project started out with a trade study. Once we found that, we researched that space and created test procedures while discussing with the team at General Dynamics. We defined and designed the prototype, and then we tested and evaluated the system requirements and the prototype requirements. To find a suitable SDR, our design considerations were to uphold the system requirements. Our team researched multiple commercially available SDRs. Based on these design considerations, the SDRs that we evaluated are the Rincon Research Raptor, the Pantech Falcon, the Edis USRP, and the Nguyen Blade RF. To create the trade study, we made the following considerations. The trade factors correspond directly to the system requirements. We determined the weights of the trade factors by consulting sponsors and analyzing the most important factors. After our final calculations from the trade study, the board that we chose was the Rincon Raptor SDR.
After the trade study was finished, we went on to our testing phase and the design of the prototype. The trade study had listed out several components that needed to be verified and tested to ensure they aligned with GDMS's requirements. A majority of verification was through testing, along with a large percent also verified through inspection of the board and its spec sheets. To ensure that all testing were up to engineering standards and fulfilled with what GDMS wanted, the team worked specifically with the GDMS engineers to rewrite these requirements until they were satisfied. These tests and results were recorded in acceptance test procedure datasheets as they were finished, either being marked as passed or failed. Some tests were not finished due to problems occurring, such as the loss of lab equipment and lab space due to COVID. Future steps will be discussed later with our plan forward on how to proceed with this. A majority of these tests though were finished and verified the 4 functional requirements and their respective system requirements given to us by GDMS. During our testing, we also participated in GDMS's electrostatic discharge training to ensure that the board and all other hardware would not be damaged. All testing and drawings were recorded in the indentured document list. As the majority of the project was testing and not design, there were not too many drawings created, but one specific drawing was the I2C/SPI breakout board.
Our prototype was designed in MVP2 to demonstrate the capabilities of the SDR board. System requirements were created based on the need of the specific communication application chosen in the prototype. Based on these requirements, a block diagram was created to show more detail on how the prototype signals will be received and transmitted. We spent a lot of time researching GNU radio so we can learn how to receive and transmit these FM signals. And we wanted to ensure that we followed all FCC regulations regarding FM and FRS radio transmissions. As mentioned previously, the Rincon Raptor was selected through our trade study, and the board was then put through verification testing to justify our selection. Our prototype utilizes the Rincon Raptor and 2 FRS radios to receive FM transmissions and then send the transmissions back over to the FRS radios. This is done through the use of GNU radio. Unfortunately, at this time, we are unable to get the FRS radios to cooperate with the Rincon Raptor and receive audio transmissions. The following shows the verification of all system requirements and classifies the verification by test, analysis, inspection, or demonstration.
Moving forward with the project, the following tests need to be completed as due to the unexpected problems coupled with the circumstances surrounding the past year that not all tests were able to be completed. These verification procedures were not completed. The transmit bandwidth, the frequency range, the transmission range, and transmission power. These are our lessons learned. You can never start early enough on testing and verification. You got to think about how much time you would need to do something and give yourself more time to do it no matter what. And always have a backup plan for everything, as we ran into issues securing lab space, acquiring the proper equipment, and the lead time delay with acquiring the SDR. These are our deliverables. The trade study was delivered on October 10th, 2020 as MVP1 to GDMS and our mentor Sharon. The testing was delivered on April 20th, 2021, delivered through verification procedures Rev C. And our prototype was delivered April 20th, 2021 through testing and as the final product.
On behalf of Team 21035, I'd like to thank everyone who has helped us through the project this past year, including the judges, our mentor Sharon, Randy and his team at GDMS for guidance and support, and Rincon Research for their cooperation.